All right, so we'll do a area under a curve to start with this. There'll be probably a couple videos to get everything out of the way. But in this question, this just you can get the heading and all that stuff down, but I've just kind of started sketching a little mini graph just to kind of give you an idea of not how easy something is, but to try and explain where this comes from in an area under curve. So I drew an f of x line and a g of x line. There's no rhyme or reason as to it. But we can do the area of a rectangle really easy, okay? So we've got our x-axis here, and let's draw a rectangle in here just like so, somewhat of a rectangle, like this. Now, these are infinitely small because, of course, we know limits and all that stuff. So I'm just going to draw it like this. So we're going to use this, and we'll use this mark here as A, and this mark here is B, okay? So we've got our f of x and our g of x, our two y's, and we got a and b as our x values. And I guess the thing that a lot of people struggle with is that the distance between these two x values we are going to call d of x. So I like to think of that as the difference, d for difference, of my x values, whatever it is. Now, of course, if we could end up using it in terms of y and have dy and all kinds of things, but this is the easiest way to start with, okay? So the distance between your a and b is d of x. And, of course, the difference, I'm going to go like this. I'm going to put it out here. The distance between your f of x and your g of x, your y values, that's obviously the height. So if I wanted to do the area of that blue rectangle, and this is what I mean by it's almost too easy that people overthink it. So I'm going to write it like this. The area of under this curve or between these two curves comes from, and we write it as an integral, definite integral, and that just means you've got boundaries, from b to a, where b is always greater than a, and our height of our rectangle is f of x minus g of x. That's what we said. So I'll put that in brackets just to keep that separate. So this is my, I'll write it in after, times the width of our rectangle is d of x, just like so. So again, this is our height of our rectangle, and this is our width of our rectangle. Okay? So now you've got that basic idea. Oh, and one other thing, I guess I should put it, I'll put it right here, where f of x is always higher than g of x. And again, it's going to come into play where you have to try to think, okay, even, especially in terms of y, like if it was f of y and g of y, you'd want to figure out which one's the higher curve. And b is also greater than a. Okay, that's not real clear, but b is greater than a. So that's the basic theory behind area under curves. I'm going to stop this video right now and give you time to kind of soak that in. And then we'll jump right into doing examples. And I'll put the steps for it as well. Now, I can't remember how many examples I'm going to show you. 1, 2, 3. I got maybe 5 examples of this stuff, maybe 6. There's some key things that we got to do. So I might break it up into 2 videos of examples for this stuff. And then once we're done that, then we can look at volume. And volume takes a bit because, like I said right there, there's 4 different types. And we might not do all 4 types that we could. We might just look at like 3 and put a stop to it there. But get that down, and then I'll throw up the next video.